Hi, my name is Stuart, and let's talk some more about 12-factor, a little bit of a deeper dive. So this is the original 12-factor manifesto, which many distributed computing practitioners think is every bit as important as the Agile manifesto, because it calls out, in our opinion, things that make distributed systems and enterprise architectures better. So let's dig in. So here are the 12 factors, and I strongly encourage you to go and read the manifesto. There's about 2 or 3 paragraphs about each of these topics, and it's an excellent thing to do. I actually have the hard copy of this slide that sits in front of me all day, where I can see it, where I can go through these. And some of these have a lot of room for opinion. So I'm not going to apologize for the fact that this presentation is going to be a little opinionated, but it's all based on the last 5 or 6 years of my work moving things out of the data center and into the cloud, and what we had to do to be successful in putting those apps into production. So a lot of the things we're going to talk about today are the results of some pretty hard-won and tough lessons learned scenarios. So Codebase. Realistically speaking, I'm going to put a stake in the ground and say the only reasonable source control system 99% of the time is Git. And you really want a hub and spoke version of Git, which means that you want your Git hosted in an enterprise environment so that you have a centralized Git that's getting backed up, where there are policies applied, where you can put in automation. And so Microsoft, Azure Dev Center, GitHub, Bitbucket, there are dozens of really good Git server platforms that have a lot of really incredible value-added features. And even if you're a sole practitioner and you're just getting along, leveraging something like GitHub or Bitbucket or something is absolutely worth doing. And for open source projects, GitHub is free, and is I think an ideal platform if you're not sure which Git is right for you or your organization. They do have enterprise features, and they do have support models. So like most open source things, you can go with the open source alternative right out of the box, or you can work with the company and pay them some money and get value-added services. Second thing is pull requests are not optional. And I'm going to go dig into that a lot more in a few minutes. The third lesson we learned is irrespective of the complexity of the software that you are trying to deploy to production, the simpler your branching structure is, the more likely you are to spend your time delivering business value and less time trying to unscramble the differences in your code between all the branches. And we'll dig into that too. You want to follow the perfect CI/CD model, and you can learn more about that and total CI by watching my video on modern development. And that includes this rubric of build once and deploy many. And then lastly, Git and enriched versions of Git support extensive metadata. So out of the box, Git has metadata about who made each commit and about history. And you can put in labels, and the labels can be part of your automation, and they can contain really useful correlations so that if you have a backlog management system, and you should, that you can relate parts of your code base to specific stories or bugs that are in your backlog. So the fundamental question of should it be in source control, super important. If you can't put it in a file, can't go in source control. If it's a secret you probably shouldn't put it in source control. That's what secret management systems and configuration management systems are all about. And yes, we have a YouTube video on that. If it's binary, that's where the going gets narrow. If you have third-party components that are only available to you as binaries, if you have scenarios where those things are not in a repository, like NuGet, or available to Composer if you're using PHP, or Gradle if you're using Java. If you really genuinely have blobs of bytes that simply don't have a home where their versioning, etc., is managed, you can enable large binary object storage on most Git systems and put them into Git. But generally speaking, for example, the output of your CI build should go into a deployment repository, not a source control repository. And they're fundamentally architected to solve two different problems. And you probably shouldn't conflate the two. So the binary thing is a tough one. And the test is, can I get these binaries from anywhere else that isn't, strictly speaking, just a file system or a file share? Because that way lies madness. Simple branching. I have seen 10 million line of code systems fit into this simple branching model. And I can tell you that there are excellent alternatives to this. Git flow is very popular. There's a set of use cases for which it's appropriate. You can go read up on that or watch a video on that. But when I sit down in the real world and I look at a customer's entire breadth of software, and I break that down by business unit, by ecosystem, by application, by deployable unit, and I think about the best way to organize that into repositories, invariably, when people tell me they need an ornate branching system, that tends to tell me that their development process is fundamentally broken. Unnecessary complexity means that you're spending money in maintaining your branching structure instead of delivering business value. The only business value that your source code repository has is that it is the repository for the intellectual property that you are creating that helps generate business value. There is no business value, typically, in ornate process I. And if you go back to the Agile Manifesto, right, which, by the way, covers more than just Agile. It covers Kanban. It covers all kinds of different development models. You know, we value people over processes. And so having smart people running a simple branching strategy beats having a complicated branching structure that, even Einstein couldn't figure out. So the simple idea of having a long line master branch that the only thing we ever branch off of it is hot fixes, and that developers work on the develop branch and we push things from develop into master when we have a release to memorialize that fact. And as we're developing features or fixing bugs, we're going to create a feature branch from develop, and we're going to use a pull request to gate that back into the master branch. And we're going to use probably a CI build or a gated build. And again, our video on modern development practices is applicable here. So always opt for simplicity. So the optimal cycle that programmers should be working in is make a feature branch and switch to it, code a little, test a little, commit, push upstream, and repeat the blue arrow cycle until you have something that is pull requestable. And again, we talk about that in the modern development video. And the upshot of that is you end up with this work cycle in Git. So the vertical slices are: local is my local machine where I'm doing my development work. Origin is my remote For me, usually that's GitHub, could be Bitbucket, could be Azure, could be whatever. And then we have the horizontal bars, which are our branches. So you can see fundamentally what we want to do is we want to start by making sure that our development branch is up to date by pulling it into our local. So doing a git pull, we want to make a feature branch or a topic branch, and we want to do our development in there. And you'll notice there's that red repeating arrow where we're constantly coding a little, testing a little, doing a commit, pushing it to origin over and over and over again. And then when we think we have an elevated set of goodness that we would like to have peer-reviewed and potentially merged into the develop branch, we are going to make a pull request. And if the pull request is rejected, we're going to go back and do the C process, and we're going to do that until our pull request passes muster or the entire idea is abandoned. And that happens, right? We do an exploratory feature and it just isn't going to work out, or it's not going to be worthwhile, and we toss it. But that's what topic branches are for. So that's the Git work cycle. And so in terms of pull requests, what we want to encourage is a pattern of many frequent pull requests, and the readiness of something, a block of code in our topic branch to be a pull request is this test. If it were integrated into the develop branch, would it A, break the world? Would it B, be ignorable? Or would it C, enrich, enhance, or advance the business functionality offered, that if we were to take the code in that branch and deploy it to QA or whatever? So your responsibility as someone who's reading a pull request is read the code. You'll notice I have a somewhat ironic feedback that said, if you didn't really read the code, go back and read the code. There's a checklist that every shop should have for pull requests, right? There's a list of things that we should do. And then, there's only two outcomes. Either we accept the pull request and it goes into the next thing, which could be a gated build. It could be a merge into the develop branch and a kickoff of a CI or whatever. Or no, we put comments in it that say, this is pretty good, but I would change this, and this, or, well, actually the requirement is blah, 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 blah. Go back and see this thing in the story or whatever. But here's the fundamental pull request flowchart. And along with that is the peer review checklist, right? It's important that we don't create process bottlenecks by making pull requests the sole province of just one or two people, right? In a perfect universe, any senior developer, any experienced developer who understands both the business and technology side should be able to take a look at pull request and use this peer review checklist, which you probably will add or subtract things for. And fundamentally, right, it's got to meet the business requirement. It's got to conform to the shop standard. You have to be confident that people have run the appropriate code cleanliness tools on it, like linters. It needs to be well documented. Again, that goes back to the shop standard, and that it represents a bite-sized chunk of work with one intention in mind, that it's dry. In other words, don't repeat yourself, and solid. And we want to avoid adding in code that we don't need right now, right? You ain't going to need it, is what YAGNI stands for. And then it just has the required metadata. And depending on your shop process, that means putting the backlog number as the first thing in your ticket, or your commit or whatever. But you want to make sure that everybody is going off the same set of rules, and that set of rules is opinionated with the opinion of the gestalt of the group, and is not one of those things where, depending on the reviewer, is the same code would either pass or fail the peer review checklist. We want to make sure that as a group that we share a common gestalt about what good code looks like. and how it should operate and certain shop standards and practices and patterns and things like that. So this brings us to dependency management. And when I speak of dependencies, and when in fact we speak of dependencies in the 12-factor universe, typically what we're talking about is everything that runs below the code you write. So, you know, one of the things about dependency management is you have to make sure that tools and technologies and libraries and stuff are all going to be on the target platform. So that's the responsibility of either the CI, the CD, or both. It may also be the responsibility of the infrastructure as code build. We want to use a package manager. And people say, well, our programming language doesn't have a package manager. And I would say, well, if it's Java, that Maven and Gradle in many ways are proxies for a package manager, although technically they're not as good as a NuGet or an NPM or a Composer. But they're almost every programming language. You can have either a package manager that's part of the tooling or an add-on to the package management that acts as a package manager. For example, Bower for JavaScript. And you want to try to isolate dependencies in code by facading over them, right? So if you have a library that deals with disk I/O, then you might want to make sure that we are consolidating all that disk I/O into very few classes, and that the API the developers are going against is framed in terms of the business, right? I want to store this document, right? That's the right level of abstraction. And that the implementation is facaded over so that if we change our file storage plan, like we move to the cloud and say, well, I'm going to put that in S3 buckets now, right? We don't have to go through the code and do brain surgery. So isolating dependencies is good. And then, you know, the unspoken elephant in the room is how are we going to keep, you know, operating systems, runtimes, and libraries up to date. And the good thing is that modern package management systems like NPM and NuGet have an audit functionality that tell you that a package has a security vulnerability or that there's new versions available. And depending on the upstream source control system in the hub and spoke model you're using, GitHub does a nice job of saying, hey, by the way, this thing has a known dependency on this particular library, and at this version, there's a vulnerability. And you may not be in a position to do something about it, but at least you're not ignorant of it, and you can make a decision based on an assessment of risk and level of effort. So the other thing is that people really have to understand your dependencies. And it's important, especially for organizations that live in the world of compliance, right? Compliance organizations need to know what third-party software is being used to deliver the business value that you're coding. And there may be licensing consequences. For example, we may have to do some sort of licensing true-up several times a year. There may be the opportunity to get technical support. So compliance and IT management can't offer you that option as a team, which can save you a ton of time when you're stuck on something or something is misbehaving if they don't know about it. If you're using open source, which is great, but open source code comes with different licensing models. The most liberal being MIT. But they have rules and conditions. And so you want to be aware of that. Your risk management group is going to want to know about all your dependencies because they're going to want to audit the system as a whole and be on the lookout for things that may cause trouble later. Configuration. We've got a bunch of videos on this, but if your configuration information is in files, in plain text, and worse, it's side by side with the code, that's dreadful, right? One of the core tenets, one of the fast five of moving things from one enterprise system to another is to externalize configuration and to make configuration go with the environment, not with the code. Because you avoid a hideous potential possibility that you deploy code into an environment, and when you deploy the code, you're deploying the configuration along with it, but the configuration is inappropriate for the environment you deployed it to. So, for example, you deploy something to QA, but it's using the production configuration, and assuming that you have been less than rigorous about separating those environments so they can't even see each other from a networking point of view, you run the risk that your QA team could then be tossing bad records into your production database, right? It's a vulnerability called security misconfiguration, which actually covers a lot more area than that, and you should really go read the OWASP material on it. But this is one of the gateway things, right? So where does configuration go? Number one rule is it goes with the environment and not with the code. If you go watch our modern development practices, we have a lot about that. We have a couple of videos on configuration management. But essentially what happens is your code and its configuration are injected into the host at deploy time. And your code starts up and acquires its configuration based on the environment, and then it does what it does. So you can do that most commonly with environment variables. You can do it by having a well-known configuration service repository. So there's an agreement among the development teams that there's always going to be a config.mycompany.internal.net, and my configuration will always be reachable from there, and which endpoint I actually get to as a function of network configuration, and therefore I will only get environment variables that are appropriate for my situation. So there's lots of different ways to skin that cat, but this is probably the one of the five things that we look at whenever we're moving code. Is we want to externalize all of the configuration, and that includes going through the code and looking for places that are hard-coded, to being not only external, but to go with the environment and not with the code. Because if we don't do that, we cannot compile once and deploy many. Backing services. So the idea behind backing services is to build an abstraction of all of the stuff that our code is going to need at runtime. Now, let's be clear, this is different from dependencies, because typically dependencies are part of the compilation or linking or dynamic runtime environment, right? They're libraries of code, typically, or they're facilities offered by the operating system or whatever. Backing services are outside of your process, right? So file systems, databases, queues, caches, web services, those are all backing services. They're not only outside of your process, they're probably outside of your host. And so we want to treat all of those things as backing services. And again, we can use service discovery, because fundamentally, how are we going to connect to them? We're going to ask our configuration management system, hey, where can I find information about the file system? And it gives it to you, and then your library code does the right thing and interacts with the file system that's environment appropriate. So the mental model is to treat everything that's outside your process boundary as a backing service, no matter how simple or how complicated the thing is. And that helps keep a separation of concerns. And in a perfect universe, right, those things are contract driven. And I'll point out that if I'm using, say, the MySQL database, that the MySQL wire protocol is effectively a contract, right? The SQL Server wire protocol is effectively a contract. The the REST over HTTP against Swagger definition is an explicit contract, right? So we want to treat things outside our process as backend services. We talked about this a little bit, right? We want to be able to have our build and release and run, and it works on my machine is not okay, right? We never want to have a scenario where we're deploying to environments from the developer's workstation. And so we need a build infrastructure, and we need, which is basically a job engine. That's what it is, right? It's a job engine that knows how to point to a process that has the tooling available to it to do whatever it needs to do to get your language into a compiled or packaged state. And, that works with compiled languages like C# and not compiled languages like PHP, but also for things that are kind of in the middle, like Java. And we want to do all of our deployments, and we want to do all of our runtime management outside of our source code management, right? These things are separate systems. And again, you can go watch our long set of videos on this topic. But it's important because if you have any part of the process that has to be done manually or requires that it be done off a particular machine, that's a warning sign for sure. So stateless share nothing processes, right? That is tricky to do, right? We have to talk about domain-driven design and separations of concerns, and we need to talk about units of work. But essentially what we want to do is we want to field our application system, which we call an ecosystem, as a set of separate deployable units that do very few things, do them really well, and as long as we don't break contracts, we can version and deploy them independently of each other, and that allows us to make changes that enhance business value without having to tie ourselves up to some sort of release schedule. If you hear the phrase release schedule or release train as part of your process, you're probably not thinking about your software process in a modern way. And your shop may have constraints that you can only do deployments on the night of 4th of July and Christmas Eve. I mean, there are regulated industries that have problems like that, but it's probably not you, right? So if you find yourself looking at something and going, man, that's pretty tightly coupled, or wow, there's a lot of cohesion, you've probably not really gotten into the spirit of these stateless share nothing services and that have distinct units of work. And the reason that's important will be pretty clear in a minute. Port binding. The truth of it is that IP networking is the networking that the world runs on for the most part. Now, there are some specialized things for that. Analog systems, things that are infrastructure, Internet of Things, airplanes, trains, things like that, they have exceptions. But most of us don't work in those worlds. Most of us work on connected networks, and that means IP networking. And that means that we want to fundamentally make sure that our backing services are a matter of a protocol over a particular port or ports, and that those ports are well-known ports, that they're well-worn protocols. And if you're designing your own systems that have their own port listeners, you should consider whether or not it's possible to adopt something like gRPC or some other high-level protocol that will make it easier for other things that come along in your business lifecycle to interoperate with. So, HTTP is very popular, right? SOAP and REST web services work over HTTP. A lot of front-end UIs now are web-based because there's basically zero deployment. now that the browser wars are mostly over. As we said before, there are some standard protocols for file systems, for email. Depending on your SQL or NoSQL client, those things typically have port-oriented, strong contracts that you can bind to. And so thinking about the world that way, right, where we're going to have how to talk to something as a matter of externalized configuration. We're going to treat them as backing services, and 99.999% of the time, we're going to try to have a port binding oriented way of talking to them. And if you do that, you'll find that you have systems that are not only very durable, but they're very flexible. They can be extended without being broken. The next problem is concurrency, right? And so in the 12-factor universe, the thing that is mostly an anathema is single points of failure. So in the web universe, right, we try to make our websites and web services stateless behind a load balancer. For our persistence tiers, we try to make them so that they're clustered, right? So that if one machine fails, the rest of our database or file system or whatever will keep running. In some cases, active-active clustering isn't an option. So you have systems that are based on an electoral thing where there's a primary and secondaries, and the secondaries will get promoted to being the primary if the primary fails. These are all good ways of dealing with it. And if you have deployable units with singletons in them, then you need to take action, because the golden rule of the 12-factor app is no singletons allowed. And I have a whole video on that. And so you can use queue mediation, you can make electoral groups, you can use primary, secondary systems like the no singletons libraries, or you can just switch technologies or approaches, but you should aim for concurrency. So a good shop standard would be we never deploy less than n of these, where n has to be greater than 1, right? And in fact, odd numbers are preferred. Disposability. This one can be tricky to understand, but basically it devolves to 3 things. Your process should start up really quickly, because if we're running it on an application host, if we're running it on a container host, if we're running it on a platform as a service host, we want things to start up quickly so that if they're behind a load balancer or they're part of a cluster or whatever, that we get systems as we scale up and down that are highly available in very short order. And the way to do that is to make sure they have really brisk startups, which means a couple of things. It implies lazy loading. It implies that we're not going to get a bunch of data and load it into static variables and put them into our memory space. So we're going to use an external cache like Redis. So when my app instance starts and needs a piece of data, Redis probably already has it, but we're going to employ a lazy loading pattern. So if it doesn't have it this time, it may have it next time. The next thing you have to be concerned about with disposability is shutdown. So if I have a process that's running and I kill it and I lose data, or the next time the process starts up, it can't restart where it left off, right? My process has to do a bunch of stuff in order to shut down, right? It takes 30 seconds, 2 minutes, 10 minutes. I swear to you, I've seen things that take, 8 to 10 minutes to shut down. These are all anathemas in distributed architectures, right? Cloud, data center, doesn't matter. Anything that's a distributed architecture based on 12-factor principles, we want to make sure they shut down. And the last thing that we want to make sure, as we spoke of before, is preserving units of work, which means that the units of work are small enough that if the process is told to shut down, it can go, give me a sec, let me finish this one unit of work, let me write where I left off, and then I'll gracefully go away. And then someone else can start and go, oh, look, there's a partially completed unit of work. I'm going to finish doing it, right? Queued mediated systems are really good for this. But there are lots of different ways to skin that cat. But essentially, especially in container systems, you have to realize that your processing can stop. And it's acutely important for headless processes, because the worst case that can happen in a process that is web facing, right, like a web service or a web page, is you get an error that it didn't finish its whatever. But the back half of those things that are working with your state boxes, like databases and storage and things like that, the real business value is in the data, right? The code is a facilitator for that. But things that cause the data to be in a bad state are very bad. And so disposability is super important. And there are lots of good strategies to get you to disposability. And it's one of the areas when I help teams migrate things to the cloud that we spend a lot of time on, because it's going to dramatically affect how successfully they're going to run as distributed systems. Developer prod parity. Vary in numeracy, not in kind. So my development environment, if I need Redis and RabbitMQ and MySQL, and I need, application hosting and whatever, the only difference between my developer environment and my prod environment is my prod environment is bigger and beefier and probably has HA and DR and business continuation and backups and all kinds of stuff like that, right? So they vary in numeracy, not in kind. If I have dramatically different technology bases from dev to int to QA to UAT to prod or whatever your environment stream is, I've done something horribly wrong, because I'm just setting myself up for being miserable. Because you'll go from environment A that has tool set A to environment B that has a completely different tool set or even a partially different tool set, and things won't work like I hope they would, and I'm going to spend all my time fighting that. So dev prod parity is this idea that we pick a tool set, we pick a base of things that we're going to use, and they're prevalent all the way through all the environments. And the only difference between dev and prod is, how many instances. In dev, I've got one web server, but in production, I've got 5 web servers. Logs. I have a whole rant on just logging, but we're going to cover the highlights. So one of the things that I see is that logging in a lot of applications, especially the older applications where it was really hard to do credible logging, right? Modern programming stacks have a plethora of good logging libraries available, right? And in the .NET universe, where I spend a lot of my time, we have Microsoft at extensions.logging, we have system.diagnostics. And then on top of those, there are beautiful logging frameworks that do all kinds of stuff. Let me point out that when you think about logging, that there are some anti-patterns as you move into distributed systems, right? Because in the old days, when I had a server and kind of everything ran on it, it was okay to write the logs to the file system, assuming you didn't run the file system out of space, and, go and collect those logs, and that's kind of okay. And then people said, well, that's still pretty inconvenient, or in production, there's this rule we can't, bounce into the server and scrape the logs. So we have to get some sort of log scraping tool or whatever, and then we got to put it somewhere. But, it turns out some of our logs have confidential stuff in them, so we got to obfuscate and blah, 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 right? It's just horrible. So developers started doing stuff like writing logs to databases. Well, if your thing you're trying to log about is that the database isn't reachable, you're not a happy camper. But every operating system on the planet Earth offers 2 output streams that are always available, generally synchronous, and 100% reliable. Standard out and standard error. And if you take the mentality as a developer that your job is to admit bad things to standard error and good things to standard out, right? And we want to be more granular than that, but just at a minimum. And that you promise not to write credit card numbers, social security numbers, passwords, stuff like that into the log stream. That collecting those logs, aggregating them and making sense of them really should be a platform problem and not your problem. And modern cloud systems, that's exactly how they work, right? If you look at application hosting alternatives, container or not, in all of the cloud systems, they all offer log aggregation, and they all say, look, if you check the box that says capture standard error and standard out for my process, that I am going to do that. And typically the great thing about writing the standard out and standard error is you're flushing it to a device, and that device generally isn't backed up. And so the impact from a performance point of view on your code, writing the standard error and standard out, is as low as it's humanly possible to be in a synchronous universe, right? And we could probably get better throughput or impact if we do them asynchronously. But the problem with asynchronicity is if your process crashes and on the way out the door, it writes a log, but the log never gets a chance to get written to somewhere useful because it's buffered. And the buffer crashes. When your process crashes, you're an unhappy camper, right? So writing the standard out and standard error represents a reasonable compromise in having a low friction logging, but also making sure that there's a fair chance that since your log data has left your process boundary, right, it's gone to the device, that you will have written it. And it beats the daylights out of file systems because in many cases, hosting systems are meant to be immutable, whether they're a process host or whether or not they're a container. Those things are meant to be immutable. And standard out and standard error are also stream oriented. And so we really want to treat logs as streams for a variety of reasons. And so that's a superior way of doing it. So here's our buttoned up logging guidance, right? And it's written in the RFC format. And we talked about most of these things already, but you should probably take a minute and wander through these and then think about your application systems and ask the question, are we doing these good things, or some of these things we probably should think about? And parenthetically, we really want to standardize across all of our application platforms what are good things and what are bad things. And if we're using standard error and standard out, the top two go to standard out and everything else, the top two things go to standard error and the bottom four things go to standard out. And we want to make sure that as a gestalt, as a group of developers and operators in QA, that we are crystal clear about when we're going to use fatal versus error versus warning versus debug versus trace and so on. So especially fatal or critical, right? The names don't really matter. There are these 6 categories and you can use fewer categories than this, but whatever category you use, it should be crystal clear what we meant when we emitted a log in that category. So fatal means the app will never run, no matter how many times the process is restarted. Generally, that means they're missing a dependency, they're missing critical path configuration, and there's just no way to recover from that. An error is just any kind of unhandled exception, and it might include the transitory unavailability of a backing system, right? The XYZ web service is transitively unavailable. So that's not fatal because it could get better on its own and then it could start working again, right? So that's an error. And a warning should be reserved for, hey, this weird thing happened. Now we handled it, but if it happens a lot more, you probably ought to give it the eyeball. Information is mostly intended for business users. We want to have a log stream that the business can filter down to and look at a chronological investigation of what happens. And generally, when we're looking for evidence of repudiation or we have a compliance issue, it is the information streams that they're going to want to filter down to. And therefore, developers should not misuse information for things that it is not intended for. Debug and trace are our technical user areas, and debugging is brief and tracing is verbose. And so depending on what we tune our system log level filtering to, if we think we have a problem, we can turn on debugging and tracing. Typically the top four are always on, and we can see what's going on, but they're going to produce a mountain of logs. And so we're going to want to turn them on, find out what's going on, fix it, and then turn them back off again. So this one is an interesting one. And it comes down to an observation that the people who wrote the 12-factor manifesto observed. And that is, you've got this beautiful system to host and operate your business value, but inevitably, you've got all these administrative tasks. You've got these jobs that run, oh, we're going to clean up this thing like, every Sunday night at 2 a.m. or we're going to, do this thing or that thing, right? And so the problem is then you go look and say, well, how did those get implemented? And they're implemented in a completely different way on a completely different system than your primary system that you're using to host your business value. And could be because there was this thing that said, well, we're going to run all these administrative things with this tool, and that's how it should be. And it could be just out of habit, and it could be out of neglect, and it could be out of the fact that no one ever thought to ask the question, could we use our normal hosting system to host our administrative processes? And the answer is, generally speaking, please do. You'll find it's much easier to have care and feeding over one application hosting platform than it is to have care and feeding over multiple ones. I'm not saying that that isn't a valid scenario sometimes, but if you can get your administrative processes to run on your primary application platform, you're probably going to be a lot happier in the long run.